Okay, so Paul, I noticed that now we're going to talk a little bit about the instruments, and actually you have two different ReactIR instruments here. Can you tell me something a little bit about the difference between them?
This is the ReactIR IC10. This is our first of our latest generation instruments that was introduced about 4 years ago. It has a very small footprint. It's about the size of a man's shoebox. This instrument can accept really any sampling technology that we've ever made. In this particular case, I have clamped to what we call the sample interface module, a DS series lab single channel interface, and it's got a little door here. And the purpose for this is that we can use our latest style of fiber optic technology, which I explained before, on this type of on the IC10. So even though this sampling technology is brand new, we've developed the interface on this instrument for that sampling technology.
Okay. And I noticed that you have two different probes in this one, linked to your 45 here. So is that the only difference between the two, being able to take two probes?
No, there are a lot of differences actually. Again, the sample interface module is the same on these two instruments. This here is the analogous version for the ReactIR 45M. The only difference really being is that we have a cable here that allows you to connect to an RTD1 input or to an RTD2 input, and RTD referring to that there's a thermocouple integrated into the tips of these probes, and these thermocouples are actually wired in, and when you connect the sampling technology to the instrument, the connection is made, and what that allows us to do is to capture the temperature of the reaction mixture at every time the sample is collected. So what we see here are these are the connections for the RTD, they're push pins. So as soon as we connect it, the connections are automatically made. We see here the lenses for the infrared energy, or I should say the fiber terminations for the infrared energy that take the infrared energy from the instrument down to the tip of the probe, and then return it from the tip of the probe to the detector. And to connect it, it's simply plug and play. And that's really all there is to setting these systems up for collecting information. Now, so that was one difference, is the fact that we can have two probes connected here. This is a multiplexer, and that's really only available on this device, and that's because, as I said, this instrument is a newer device, so it was designed for the multiplexer. There's a power cable here that connects it, and there are two RTD inputs, so we can collect the temperature from both probes at the same time. The other thing you'll notice is that we have a power and scan indicator here, but here we have more information, so there are more diagnostic elements with this instrument. You'll see here a little snorkel. That's to actually read external temperature, which could be useful. But you'll see that we have MCT OK, so that really tells us if our detector is cold enough. And the temperature OK tells us if the internal temperature has stabilized and is at the correct temperature. So really, when all four lights are on, it really indicates that we're ready to collect high-quality information about our reactions.
Paul, so you mentioned there's an internal temperature indicator here which indicates when the instrument's ready. So is that another difference between the two instruments?
Yes, Adrian, that is a difference between the two instruments. This instrument here has a thermoelectric cooler inside. You can see that it's raised in the back here versus this one here. So there is more inside of this instrument. There's a thermoelectric cooler, and we modulate the temperature of inside and keep the interferometer at a very stable temperature so that we get very good long-term stability with this instrument.